Hello, everybody. My name is Juliana Pakitei. I'm the Master Coordinator of Biomedical Engineering Master Program at TU Delft. And on behalf of the entire education team of this program, I give you a warm welcome. So for the next 20-25 minutes, I'm trying to present you the master program at TU Delft to give you some hints here, and then we'll have time to answer some questions if you will have them. So let's go. So the Biomedical Engineering Master Program, it's a multidisciplinary program, and our aim is just to provide this multidisciplinary program which will provide you a good, I would say, understanding about the biology, human biology mostly, and medical theory here in one side, but on a highly specialized technical training in the fields like physics, electrical, materials, and mechanical engineering. So actually, one side we have two pillars here. We definitely try to provide you good training in biology and medical theory, but at the same time, enough foundation, a good foundation of engineering sciences here. So you should have a good, and for this program, you should have a good engineering, I would say, background, but not entirely necessary. Biomedical engineering, it's definitely multidisciplinary. So even in this program, we are interfaculty master program, and this interfaculty master program consists of three faculties here. So three faculties joins to do this master program. One is called Mechanical, Maritime, and Materials Engineering, 3ME, Applied Sciences, the second one, mostly the physics part, Electrical Engineering, Mathematics, and Computer Science is the third faculty here. So you already see all these, you'll have teachers from all these, I would say, faculties here who are involved in biomedical engineering, but the administration part of the program is done under the 3ME faculty. Okay, next to our internal collaboration in TU Delft, we have external collaboration, and we team up with colleagues from different medical centers in the Netherlands here, like we have the Leiden, Erasmus, or Amsterdam Medical Center, or Free University Medical Center of Amsterdam, and also Utrecht and Maastricht medical centers as well. So it means that you may have research projects in collaboration with this, especially for a graduation, that you can take internships here, and some of these people are involved in even in teaching several lectures or even some courses. Yeah, biomedical engineering as a research field, but also education field, is quite hot in this sense from the research point of view, that because biomedical engineering is one of the, I would say, research initiative on TU Delft called Health. At the same time, you will see that biomedical engineering is part of medical data platform here, or collaboration between Delft, Leiden, and Rotterdam. Delft is the only technological knowledge center within this area here, between two medical centers, Leiden and Rotterdam, and we joined together to create this platform. Then at the same time, biomedical engineering is part of Twente Eindhoven Groningen University. So there are master programs organized by this, but I will show you soon that there are some differences between this. At the same time, it's a priority of Dutch government and of course for European Union. Why this? Because I think, okay, right now we're in the Corona time, something which we as a world we not expected too much. But on the other hand, before that time, and still is going on, we are living in a quite aging population. And you can see here this red line, which is presenting the segment of people over 65. You see is growing. So it means that we need to be prepared to really help those people. Because whatever it is, we are a biological system, we age, we have different diseases, but not, we can take care about those diseases and prolong our life as much as possible. And you can see, for instance, the Netherlands, around 2025, more than 20% of the population will be over 65. It means that with current technology, what we have so far, more than 25% of the population in the Netherlands should work in the healthcare, and this will be quite expensive, I would say. So this will cost the Netherlands GNP more than 10%. So I would say it's quite expensive. Quite a lot of population should work here. So therefore, the only thing to really overcome all those problems right now is to also invest as much as possible in technology, which can sustain definitely the level of healthcare. So we need to really work on medical devices and the many aspects related to the healthcare systems to help those people who need it. Biomedical engineering education in the Netherlands, if you take a look here, because as I said earlier, it's an interdisciplinary field or multidisciplinary field. So on one hand, we have the engineering part, on the other hand, we have the medical sciences. And you can see biomedical engineering as a program is somewhere a little bit much more closer to the engineering part, because it's engineering you have in those words here. And compared, for instance, with other type of postgraduate education in the Netherlands was technical medicine. There is another master program here in Tilburg, which is called technical medicine. They are much more closer to the clinical part. But if we zoom in the yellow square here, what I present you here, biomedical engineering here, to see what are the differences between biomedical engineering at TU Delft and the other University Twente, Eindhoven, Groningen, you will see, for instance, TU Delft biomedical engineering is much more closer to the engineering part, to physics, mathematics, with those fundamental sciences, compared to the others, the other universities which are towards, I would say, the clinical part. I want just to draw your attention on one point here. You may hear also, or you have seen already, there is another master program in mechanical engineering faculty called Mechanical Engineering Biomechanical Design track. So the program is called Mechanical Engineering. There is a track which is called Biomechanical Design, and that part we see is much more closer here towards to, I would say, to engineering part, to mechanical engineering. It's pure mechanical engineering track. Even more, I can give you some differences here. So you may hear about this track, biomechanical design. What are the big differences between biomechanical design track within mechanical engineering master program and biomedical engineering master program? Biomedical engineering is a master program per se. So the big difference that in the case of biomechanical design, your colleagues will look to, or will use biology, human biology, or I would say, yes, nature, for instance, an inspiration tool to design specific devices which can be used for different type of engineering application, not exactly for medical part. In the case of biomedical engineering master program, this is clinical oriented. It's the part of design, research, manufacturing, everything is done towards clinical part. Actually, you will design and manufacture, and you will do modeling, whatever, here just to take care about, I would say, patients. In the end, the patient will be helped, or you will, at least try to equip those physicians to treat the patient in a normal way. So it's much more concentrated on pathology compared to the biomechanical design, which is concentrated on physiology part. I hope I can make a little bit clear with this one. Okay, the program itself. The program is 2 years, consists of, in total is 120 ECs, definitely. First year you have to acquire 60 ECs through the courses, and these courses are compulsory for all the BME students, for all the students, some of them. You will have also devoted courses for each track, because I will show shortly the structure of the program, and also you have around 25% for room for electives. Second year will have a structure which consists, you have a little bit of flexibility in choosing certain things, but not too much here compared to first year. You can do either an internship or a joint interdisciplinary project or electives. You can choose between these 3 items, and then you have to take it literature study or literature review, and definitely the biggest part here will be the graduation project. Yeah, here's just, I will not have time to go through all of these, but these are just example of the courses. We have more than 60 courses in this master program. Of course, you don't have to take all of them, but depends on the track. Some of them you have to take, so these are just examples. And actually, when you enroll in this master program, in the first week we introduce the program is for all the master in Delft, and then it will get a lot of information how to really enroll properly in this program. Usually you have to fill in an individual study program per track, and then that's the time when you talk with your track coordinator and it help you to really get the exact course what you want to do it. And even so, it will not be, I would say, probably the proper ones. Maybe later we can also change them. So there is some flexibility, but that you will learn in the first week when you join the program. More information about this master program, you can find it on our webpage. I think most of you already have seen this webpage. We try to keep it up to date, the most important information already here. So I would advise you to visit this webpage. You can see, for instance, information about the program in detail, the structure of the courses, the most important courses here. There are every year they'll be slightly changing. For instance, this is for the current academic year, will be next year a little bit slightly changing, not too much. So feel free to look and yeah, get your idea. So for instance, just an overview of those courses, what will be for the next year per track. I will not go through this, but you can see already are quite a lot of courses, and some of them are compulsory for tracks, per each tracks. And you can take always an elective from as an elective, something which is compulsory for other tracks. So the combination also are possible here. Even more, if you want to look in our master program, if you go to TU Delft study guides, tu.delft.nl, you will see, and you choose here on the left corner the exact faculty and master program. You will also be able to see the entire structure of the program and even read about those courses, what you will be doing, special study goals and examination methods, who is involved in the organization of that course, and you can write email if you want more information about specific courses. Now it will bring me to present to the structure of this master program. And the structure of the master program is already can see here. We are divided in 3 tracks. Track number 1, which is called neuromusculoskeletal biomechanics. Track number 2, which is called medical devices, and track number 3, which is called medical physics. Let's give you some slides, some brief overview about this, what you can do and what kind of research topics and kind of, I would say, activities you will do in this track. So actually the main goal of neuromusculoskeletal biomechanics track is to maintain, enhance and support the physical activities, about mobility, how we can keep the mobility of patients, but also healthy performance, for instance, those who are working in sports, or trainers to train specific people here with the performance, especially for sports engineering. You will see and recognize how important is the neuromusculoskeletal system here, because it really controls our physical activity here. An example of focus area of research and graduation project, kind of specialization, if you want to call it such, later on in the program, we have biomechatronics, we have tissue biomechanics, we have sports engineering, we have prosthetic and orthosic, for instance, and many other cardiovascular biomechanics, few more. I'm not have time to go through all of this. You will hear it when you'll be in the program. For instance, for example, I can give you the biomechatronics part here. This is a kind of diagram always you will find here, where we try to have some input parameter here, and then we can see what are the output here, and within we design specific, I would say, or we take into account different parts of our body here, like the brain. For instance, you see how the muscle respond in the case of a shoulder, and then you can acquire. You can introduce here different perturbation at a certain time, and you see how the human body will behave, and that you understand the behavior of the human body in certain circumstances. It could be a disease, could be other challenge, and this is a kind of robot what you sometimes try to acquire those data or introduce the perturbation, and you can get the force, the momentum, and then you can model later on and give the physicians the good answer on specific disease. Tissue biomechanics, definitely mostly we concentrate here on, I would say, on the musculoskeletal system, and the main part of the musculoskeletal system are bone, cartilage, tendon, and ligaments. Yeah, it's difficult to go through all of this, but you already, probably some of you already know, is in the left part is the normal bone. This is trabecular porous bone, the middle part of long bones here. At a certain time, because of aging, this bone will change the properties, the mechanical properties, because the porosity is getting higher. Yeah, it's enlarging, and also the trabecula are getting thin, which is always will be a risk for cracking. But using engineering tools like finite element modeling, for instance, here you can try to predict how will be the distribution of the force in the specific patient, the age taken into account, the activity of that person, what he or she is doing, and then you can really predict some cracks which can appear and give some good information for the orthopedic surgeon here to really advise the patient on maybe in certain time to take some actions. Sports engineering is another part of this master program here. Some selected topics, I would say, not everything here, where we definitely, on one side, we can concentrate on performance, like we see in this picture here, and trainers, and you can try to measure a lot of parameters nowadays, and also give yeah, those specialists here some hints to really behave really sometimes to win 1 second, or maybe want to be a good performance. You can use, for instance, equipment like this bike here, instrumented bike with a lot of equipment here controlling the steering, the inclination, the speed, many parameters can control, and later when you try to model this and see what happens in certain circumstances. Then also here you can work on designing different type of prostheses here. These are examples for this transtibial prosthesis, where those patients actually which are healthy, but they lost part of their limbs here, they can really do good performance in specific sports. And see an example here. You can, there are a lot of things to study here and design those prostheses, but also to control the movement of the body, and especially in relation with the brain. This brings me to a second track now, medical devices track. The medical devices track is aiming on designing, manufacturing, and testing of advanced medical devices. Mostly here we try to keep in mind that we want to maximize the functionality of those medical devices and keep them, I'd say, to create minimal invasiveness in the way that we don't want to damage the tissue around or create tissue defects, which will later will create a trauma for the patient, or maybe be more complex to heal up. Example of the focus research area here are medical instruments and medical safety, biomaterials and implants, bioelectronics and bioelectrics and MEMS, also prosthetic and orthotic in terms of manufacturing of this. In the case of medical instruments, I want to give you some example. You see, they try, my colleagues here try to design instruments which are steerable, definitely, but at the same time to use natural openings of the body to really minimize the damaging of the tissue. And as I said earlier, they should be steerable. They should have the possibility to really go around specific parts or organs in the body, which cannot be damaging. Imagine you can have something in the brain. You need to use probably the nose or another part of the opening and go, of course, with a good guiding here, go to the tumors and try to avoid many parts of I would say, of the head in the way that not to damage them. So this is quite challenging, but interesting to do. DORA system, this is something which TU Delft was famous, has been designed in the past in our faculty, in our, actually, okay, in TU Delft, it's more groups are contributed. This DORA is called Digital Operating Room Assistant system, which is a kind of, is inspired from aviation. It's kind of black box, and actually they record everything what is happening in the operation room in the way that they take care about safety. If something goes wrong, they can look back and see what went wrong. In this case, they will try to avoid this for the next time. So these kind of system, as far as I know, at least in the Netherlands, is trying to be implemented in all the hospitals, at least the new hospitals, the new equipment. It's a kind of must, I would say, right now, at least in my knowledge. Yeah, this is another part of this track is called Biomedical implants, another focus area here, and this is the research what we do here. Mostly we try to design implants and medical devices. They are much more complex for definitely not to be one size fits all, but mostly to try to design specific I mean just to patient-specific implants. So if you have a defect, then you can scan that particular defect, and then can you put it in on a computer, and then you can design the exact implant requirements that you need, so patient-specific implants. 3D printing is a technology which actually a few years ago was not available. Right now, it's available for different type of biomaterials, for polymeric metals, ceramics as well, and we can create implants which have the possibility to follow the anatomy of a specific part of the body, like I have this example here, which is following the hip implants, the upper part of the hip implant, femoral head here, and then yeah, just as an example, but we can do much more complex things. And I would say next step here is not only just to design those implants which will follow the anatomy of that particular defect, but we try to biofunctionalize them. So those implants, most of them are made from titanium. They need to bridge with the bone to create a biological fixation in the end. But at the same time, we need to take care about, for instance, infection. So you need multifunctional implants for medical devices which can instruct the tissue and heal up faster, take care about infections, have a kind of switch on and switch off behavior, be also controllable from distance nowadays, wireless. So it's quite complex and quite a lot of challenges ahead here, and really fascinating. Biomaterials and implants also, we work also on other type of implants, not only for the orthopedic part, but also for the cardiovascular, like you see this stent here, which is trying to open the stenotic artery on the heart, on the cardiovascular system here. So a lot of things to design these stents and to make them even vanish away to be biodegradable. This is a lot of challenges ahead. Bioelectronics, my colleagues also work here, especially in the AV faculty and the electrical engineering here, to design smart sensors to measure a lot of parameters nowadays we need to measure in the human body. Oxygen pressure, temperature, many parameters. And the challenge is that to put this eventually on a small computer and to measure a lot of parameters in a tiny part of the human body, also not to be invasive as well. This is really fascinating and challenging. Yeah, different type of diseases using neuroprosthesis here on the brain, like Alzheimer or Parkinson, can be treated by stimulating specific parts of the brain, and nowadays you can use and design those devices to treat specific patients. Prosthetic and orthotics definitely is part of this track as well, designing and manufacturing different type of prostheses, body powder prosthesis in the way that yeah, you can do normal things with such a prosthesis, but at the same time to be cheaper. Nowadays with 3D printing technologies, you can design much more anatomical looking prosthesis, and of course, yeah, they should be available for people actually who are in need. Children, for instance, they really see how happy they are when they feel that something what they lost in a war, I don't know, by other things, they feel that yeah, they are normal again. That is fantastic. Track number 3, few words about track number 3. Track number 3, medical physics. The focus is on physical methods used in diagnosing and therapy here. As examples of focus areas here are medical imaging and radiotherapy. And by the way, this program is, or this track, if you finish this track, you have the possibility to join clinical physics, a kind of post-academic education. Only for if you follow this track, the other track not. In case of imaging processing, it's a very important part what my colleagues are doing in applied physics here. So they use a lot of, nowadays we have a very lot of imaging techniques, MRI scanning, many others, and they try to combine using software, so they design specific software and really look to the, for instance, tumors or the defect, and they want to do a surgery later or at least give good information to the physician here to take a good decision. This is quite challenging as well to really design this. In the case of radiotherapy, also they use these imaging techniques to really delineate between a tumor or diseased tissue and healthy tissue here, and to minimize as much as possible, or to preserve the healthy tissue and treat only the tumor tissue here. So they use different type of tools here and it's really very much appreciated nowadays. This type of imaging techniques, they are really rapidly developing. So we need to keep going. Keep in mind that by the end of the campus, there is a proton therapy center here, kind of clinic where you as a master together with PhD and staff, they work here using proton therapy. This is, I would say, proton therapy. It's a kind of technology which help you to really minimize the damage of the tissue in the case of radiotherapy. This is interesting. Okay, for the 4 or 5 minutes, I'm trying to show you some facilities here. And we have a small movie here for around, this movie also is available on our website. Maybe some of you already visited, but I will try to run it.
The Biomedical Engineering program at Delft University of Technology is an interfaculty postgraduate program with participating research departments from 3 different faculties. That includes Faculty of Mechanical, Maritime, Materials Engineering, Faculty of Applied Sciences, and Faculty of Electrical Engineering, Mathematics, and Computer Science. We have 3 tracks in this program that includes neuromusculoskeletal biomechanics, medical devices, and medical physics. In this video, we would like to present some of the research facilities that are used for the training of biomedical engineering students.
Track 1, neuromusculoskeletal biomechanics. The GATE Lab. The GATE Lab is used to study the biomechanics and motor control of human movement, employing motion capture, ground reaction forces, and 16-channel electromyography. The Neuromechanics and Motor Control Lab. The Neuromechanics and Motor Control Lab has force-controlled robotics for system identification of the human limbs to expedite diagnostics and improve therapy of movement disorders. The EEG Lab. In the EEG Lab, high-end EEG measurements enable the tracking of sensory and motor signals throughout the cortex. The Tissue Biomechanics Lab. The mechanical properties of biological tissues are characterized under uniaxial and multiaxial loading in the Tissue Biomechanics Lab. Our facilities allow for this characterization at various length scales and under both quasi-static and dynamic loading. The Bicycle Lab. At the Bicycle Lab, we research the dynamics and control of bicycles. We study the dynamics of the bicycle rider system to understand how humans control bicycles. Track 2, Medical Devices. The Additive Manufacturing Lab. Our Additive Manufacturing Lab has been pioneering the application of 3D printing techniques for fabrication of medical devices with a focus on metallic and polymeric materials. The Biomaterials Characterization Lab. The Biomaterials Characterization Lab uses advanced techniques to perform physicochemical characterization of biomaterials and biomaterial cell interactions. The Biomaterials Surface Biofunctionalization Lab. The Biomaterials Surface Biofunctionalization Lab has unique equipment such as plasma electrolytic oxidation to make multifunctional implants and biomaterials. The El Sequoia Lab. At the El Sequoia Lab, students learn about biomicroelectromechanical structures, biosensors, biomedical circuits and systems, biomedical signal processing, and biomedical microsystems. The Biomedical Electronics Lab. At the Biomedical Electronics Lab, students can process their own devices, chips, microsystems, and algorithms, as well as testing technical, in vitro, and in vivo functionalities. The Bio-Inspired Technology Group. In the Bio-Inspired Technology Group, we aim to develop innovative medical devices inspired by clever biological solutions in nature, for example, snake-like surgical instruments. The Cytocompatibility and Biointerfaces Lab. The Cytocompatibility and Biointerfaces Lab is a dedicated, state-of-the-art facility for assessing the in vitro effects of biomaterials on the cell's behavior. The Minimally Invasive Surgery and Interventional Techniques Lab. The Minimally Invasive Surgery and Interventional Techniques Lab has a fully equipped mock-up operation room used to develop and test innovative surgical instruments and training systems for minimally invasive interventions. The Prosthetics and Orthotics Lab. In the Prosthetics and Orthotics Lab, we design and evaluate innovative assistive devices based on new principles like microhydraulics, hybrid actuation, and self-grasping mechanisms. Track 3, Medical Physics. The Holland Proton Therapy Center. Holland Proton Therapy Center is the independent clinic and research center in which TU Delft, Leiden University Medical Center, and Erasmus Medical Center collaborate in providing excellent care and groundbreaking research. The research focuses on the application of advanced imaging to make proton therapy more accurate and to spare the surrounding tissue. The Medical Image Processing Lab. In the Medical Image Processing Lab, students work on medical image processing problems using dedicated software packages. The Transducer Lab. In the Transducer Lab, students develop their own measurement devices and perform experiments using ultrasound transducers. Biomedical Engineering Master's Program.
Good. Okay, now I'm going for the last part to give you some practical information about this master program. First of all, how many students are enrolled almost every year in this master program? You already can see around 130, 35, 36 here. Then it's an international program, definitely around 25% are coming from other countries. And we have a good gender division here, it's 50 to 50 roughly. Who is eligible for this master program? So without any bridging program here, you see these are the bachelor university backgrounds. They can enroll directly to this master program. It's mechanical engineering or maritime, electrical engineering, applied physics. These are the faculties actually which are involved in organization of this master program. Then you have also aerospace engineering. They can join directly. Biomedical engineering from 20 and Groningen. But there is a but here, especially for those who, for the Groningen, those who follow the major in biomedical engineering. Medical science and technology from 20 and advanced technology also from, sorry, from Eindhoven it was, and this is advanced technology from 20. More details and information about this, you can visit our webpage. And if you go on our webpage here, you see at a certain time an admission application, the bridging program, this red circle here, and then you, for international students, you also can see who can be directly admitted. And then here you get to this table. It's quite big. I will not have time to go through this. And you, if you find a program here that's good, and if it's not a program here, definitely you are not eligible for this master program. If you need more information about certain things, you can always email us on this email address, and we try to answer you as much as quick as possible to give you the right answer. We don't know how the things will be for the next academic year. This year was everything under Corona, situation, I would say that, and then I would like you also, if you want to join the program, also to keep looking on our webpage here, because we give a lot of information. So if you know the proper information before you join the master program. Where you can find a job? Definitely, these are just examples. You can find a job after this in companies, in university and research institutes, or other sectors in companies, big players in the world, like Philips Healthcare, like Siemens, Cordix, Zimmer Biomed, Medtronics, are, but also small companies in the Netherlands and also abroad. University around here in the Netherlands, but also outside of the Netherlands, and also you can find a job in finance management. I have also some colleagues of who they went to ABN AMRO and other, I would say, banks, then because they also to invest in biomedical engineering. They want to have good specialists here, also in government bodies, in healthcare system, many other. Then you have to know also you have your colleagues here from Antonio van Leeuwenhoek Society here, who can help you finding your way in TU Delft more than we as a staff. You can talk with them, and because also, at least in the good times, not so easy right now, they organize a lot of activities, but they still manage workshops, company visits. Hopefully it will come back good time. They will do it again for your generation. Also other social activities, drinks before and the end of academic year, and barbecues, and maybe educational affairs. Okay, I don't know how the healthcare system of tomorrow will look. I don't know, something like that. I just took some pictures, but I'm sure that you guys, you will have the possibility to influence it, to have something to say in this field. With this, I finish my presentation, and thank you very much for your attention. And now it's time for some questions. So I will stop sharing my screen. And now it's time for questions. Any questions so far?
There are some questions. Wait a minute. I'm just answering one now. Yeah, there are some questions. You can hear me, right?
I can hear it, yeah.
Yeah, okay, nice. Yeah, there was a question. It's about someone who asked, can you follow all tracks? And how do you find out which track you can follow? And what is it like for pre-master students?
Yeah, so for those who want to join this master program, of course, when they enroll, for instance, studying right now, maybe you have to pick up a track, but you have still the possibility to choose a track in September. Actually, it will be the time when you decide about your track. So actually, you can follow. You can make a choice right now, and then in September you can choose another track. It's not a problem, but you can't follow all the tracks in the master, so you have to choose for one track. I don't know if this is the answer they are looking for, but that's, yeah. Yeah,
and how to find out what your which bridging program you need to do or need to follow for which track? Are there
actually, if they follow one bridging program for a specific specialization or they were bachelor, they can join later on any track. They can enroll in any track they want, so they don't really have to do it per track. So those bridging programs, except for HBO students, there are indications on our website. There is a this bridging table. They can take a look on our website on the bridging table and can find out. But for those with a university degree, they don't have to do it. And even for those with HBO, later on they can choose if they took one track when they enroll in the bridging. Later on, also they can choose another track if they want. So we allow this possibility.
Okay, thank you. Yeah, because there was also another question. Someone who did the Bachelor of Biomedical Sciences and how to find out if you need to do a bridge program, but that's on the same.
Yeah, it's on the same. So they have to visit our website and they go there. There are instructions. If they have any questions, this SCAFL email address they can write, and then they can get an answer, or write to the master coordinator later on, and they can get advice. Yeah.
Yeah. Okay. Thanks. Another question. Someone asked if it's possible to follow this master dual.
Sorry, to follow?
Dual, like part-time.
No, no. This is a program. Yeah, we don't control this, but actually, I advise who is enrolled in this master program. It's a full program. It's a daily program. There are activities they have to come every day. So if they lose certain courses or yeah, they will delay the program. It's not advisable at all. No.
Yeah, then another question. Someone asked, what's the ratio of lectures and lab sessions?
Yeah, I mean, each course has its own design. So sometimes you have lab activities, sometimes you have other activities, design activities. You have so it's yeah. I mean, there is a balance between lectures. So each I would say, teacher and responsible instructor for each course has his own. It's not like a bachelor. So but it's. I mean, for instance, there are courses you have just courses, and then at a certain time you have a research project. You have to do that research project, and then yeah. Then your grade, for instance, make it by the exam, which is for those courses and also combined with those projects, or you may have presentations. So there are different things. It's a good balance between all of these because our courses are in that way.
Okay, thank you. Then another question. I think it's on the same page, but where to apply for a bridging program if you need to do it?
So there is for the bridging program, they have to go to this scaffold. So it's also on the website written.
Yeah. Okay.
And there is also a website specific for the scaffold program. If they write to this email on the CME scaffold at student.nl, then they will get. So I also present the email in my presentation today to be recorded.
Yeah, and there was someone interested in prosthetics, but he said BMD might be more relevant, and his question was, would it still be possible to have more practice in the prosthetics or orthotics lab if he did or she did the BMD?
So if she did BMD, what actually is like the question? What they want to know? If there are possibilities,
practice in the prosthetics lab. If
they can do, yeah, they can do definitely. I mean, as I said, probably some people from BMD also because the staff member are pretty at the same, but the research projects are designed in based on the background of the student. So we may have certain things related to prosthetic and orthotics will be for those students who have a mechanical engineering background, who are following the I would say the course structure and yeah, get the background of BMD, and it will be different compared to someone who actually is doing BME here in this. So the project will be different. So in the case of the students following the BME, based on their background, they will be toward the clinical, to more application, to really probably test those prostheses on patients if possible, some project like that. Or maybe go abroad, for instance, in other countries and also do the research there. There are, right now it's difficult with Corona, but before Corona time, we had those projects in outside of Delft and outside of Netherlands. There are.
Thank you. Another question, how many ECTs are the electives and does it differ from tracks?
No, the electives are pretty the same, the number. So I put roughly around 25%, up to 25% you can take electives. This is within those 120 ECs. But if someone wants to take more electives, they want to make honors program or something like that, maybe they can put on top of this. But we consider that around 22, 24, 25%. Yeah, it's a good possibility to fine-tune your background. So,
okay, thank you. Another question, how much work in this field is done on the computer? For example, programming and modeling.
Quite a lot. Many courses are even called computational biomechanics, for instance, in track number 1 and in track number 3 as well. A lot of, I would say, a lot of those softwares are sometimes developed by my colleagues or they, work. So it's quite a lot of computer work. Computers are, yeah, engineering tools nowadays, definitely you will use it a lot.
Okay, another one. Can you do the master biomedical engineering with the standard mechanical engineering pre-master?
With the standard, it depends. Yeah, it depends. I need more information about it. It depends from where it's coming. So I need more information about this. But if they've done a pre-master for mechanical engineering, roughly they have to take a look, because I need more information about it. So I will not give right now an answer. I need better to send an email to me as a master coordinator, and I will take a look and give a specific answer. Yeah, okay. I will need because this is a little bit tricky. I need to know the background from where that person is coming, that student is coming.
Okay, thank you. Another question. I'm not sure if you can answer this one. What's the main difference between the BME master and the BME profile inside the electrical engineering master?
I'm not acquainted with that particular in electrical engineering, but I think, at least as far as I am concerned, our master program, it's much and good balance between engineering part and clinical application. So we really do in this master program, not it's a combination between mechanics, electrical part, and physics quite a lot, clinics quite a lot. You see, we take a lot of things which are, you can even in this master program, you can do research involving sensor, but with in vitro, and sometimes you can do an animal study, which I don't think the other master programs they can do. So this is, yeah, it's quite a difference, So this is the only biomedical engineering master program in Delft in this area. I don't think that one is there is not an overlap. Maybe some courses could be an overlap, but doesn't mean if one or two courses is overlapped, then all program. No. Okay. I hope I could answer. I don't know. I need more information.
If you want to go abroad, is it like the bachelor's that you will follow courses at another university, or can you also do an internship or something like that?
Yeah, it's possible to go abroad. Definitely, this you have to talk with your track coordinator, with a master coordinator. It depends. Of course, you can do an internship abroad. Definitely, if you find it yourself, sometimes through our networks, one of the teachers, definitely we can go. Courses also we can take abroad as well, but we need to see, actually you are not allowed more than around 10 EC to take it abroad, and if it's compulsory course you need approval. So it's possible, but will be a fine tuning, some discussion. It's not something I go abroad and come back, I brought 2-3 courses and I want to put them in my program. No, you have to discuss beforehand. I don't think there will be any problem if you give a good justification, because yeah, the idea is to have a good education, to have the right knowledge, to yeah, have in the end a good performance in the program and later on. So we need to, it's possible. So it's the answer shortly, it's possible, but based on the discussion with the people involved, especially master coordinator, track coordinators. Yeah.
Okay. Another one, would we be able to continue a PhD with the same master thesis topic, yeah, or start a PhD from the second year?
Yeah, definitely. That's it is something. It's part of our aim. Definitely, I have myself my master students, so I had so far quite a lot who actually one of them just finished right now. The PhD was very good master student. So definitely, yeah, it's possible. Definitely, yeah. We encourage if we have, of course, yeah. If we, I mean, the project, I mean, PhD position in TU Delft and in this area are based on projects. So if you have a project in that one, and we always apply for this, yeah, definitely we want to involve and take master students who want to do academic career or at least a PhD. Yeah, then they can do.
Okay, nice. What's the difference between the medical physics tracks and the applied physics track, physics for health and life? Why would you choose one over the other? Yeah,
also I don't know too much those tracks from other master program, but I suppose that this is a physics, somebody with a physical background, and I would say that still in our part we are very much more clinical oriented here, and also good balance between the engineering part and this, I would say, because this is the old program. But I would advise that particular person to write an email to the track coordinator of track number 3 medical physics, Dr. Franz Boos, and I'm sure he will answer much more, I mean, given fine-tuned answer here. Or otherwise, write to me, and then you can write to me and I will direct it to him. Yeah, so that particular student can write it to me, and then I will ask my colleague to give more information.
Okay, someone is very interested in sport mechanics. Would you suggest the neuro track or the medical devices track?
No, track number 1. So neuro, musculoskeletal biomechanics, yeah, for sports engineering. So this is because it's a lot of neuro part involved here. So it's good to track number 1. Track number 1. Okay.
Another question: what's the application deadline?
Application deadline. Yeah. I don't know if it's a Dutch student or international student who is asking here. So there are different, for Dutch students, they can apply till the end of this academic year, till August. And even, we have the enrollment in September. We start the master in September, so we can apply till the end of August. But better to do it in advance, because we need to know how many students are in our program just in September. So, but you can apply till the end of this academic year.
Okay, another question: is there a lot of interaction with medical experts like surgeons and cardiologists during the study?
Yes, definitely, quite a lot. We in many areas and many aspects of our research activities, we interact with them. We have them also teaching. I have also in my course colleagues from different clinics or from medical centers. Definitely they are involved quite a lot. This is why even sometimes we advise them, what is possible, definitely, to have also tutor also from clinic part. And most of the time we supply this, so always students can be sent to Erasmus or Leiden. They can do an internship there and coming back for a thesis here, but also or the other way around. Definitely there is a lot of collaborations.
Okay, thank you. Another question: how would you describe the profile of someone who is likely to get accepted?
To describe the profile of someone to get acceptance of what?
Yep. How would you describe that?
In the program?
No, I think it's more for someone to get accepted for the master, maybe? I'm not sure.
Not clear exactly what they mean by this question, but I mean, yeah, anyone who actually already who is eligible for this master program already placed that information on my presentation, but also it's available on the website. So if you have a mechanical engineering background, electrical engineering background, not computer science, because you need to do some bridging here. Definitely biomedical engineering from Groningen with the major in biomedical engineering, life science and technology with a major in biomedical. People also coming from, I would say, from medicine, or also they can come as well. The only thing, they have to do a good, quite large bridging program here, but also they are suitable. So just take a look on the bridging table and you find, those backgrounds, as long as they are discussed here and allowed to enter this master, all of them are. So, I mean, in the end, we teach engineers here. In someone who will finish this master program will be an engineer, but well equipped with enough theoretical part and practical part and skills to really embrace a career in the biomedical field. So, which is it's booming right now. They are needed in many activities in hospitals, in healthcare system, in government, but in companies definitely. Yeah.
Okay.
I hope I could give some answer.
Yeah. Can you end up working in a hospital closely with surgeons, for instance?
Yeah. I had colleagues of you in the past. They were really doing an operation together with the surgeon. For instance, someone who developed instruments, or someone who actually is working by a company which has a knee implant. They know, they are trained how to do this operation. They know with that instrument, and they give help to those physicians or surgeons in the operating room. Definitely.
So that's also inside the body.
Yeah,
like,
yeah. Okay, they not perform the operation per se because they are not, but they can assist and advise, do it like that, do it like that, use specific instruments, they can do such a thing. Or, put the implant in that direction, they can, they can be in the operating room.
But can they also design like the things for inside the body?
What kind of things? Implants or for the body?
Yeah, for replacing organs.
Yeah, they can. Of course, they will play a role in the design part because all of these are firstly designed. You think and then you produce, you manufacture them. Yeah, also it's part of the design, definitely, because this is the point. Biomedical engineers are needed because it's really not, I would say, it's not a gap, but it's a good link between engineers which are equipped with a lot of technological things, a lot of also fundamental sciences, mathematics, physics, chemistry, some of them, and other design part, all those things. And if you know and understand the anatomy and many other things are happening in the human body, you will be able definitely to help those surgeons or physicians, whatever they are, to perform better. And they will never ever have time to learn technology. They will not learn the engineering tool. They will not be so skilled in mathematics to solve those things. So therefore, it's for them, when they feel much more confident, we have a biomedical engineer, especially from that.
Okay. What's the deadline to sign up for the bridging program?
I think for the bridging, you have to do it somewhere till, I'm not sure for exactly for this, but you can also send an email, we can check, but I think it's, things change a little bit. I think 1st of July is the latest day. You have to do it before 1st of July. Okay. But I'm not sure 100%, we need to check. So an email to the SCAFL program will help, or to me, and I will forward to them.
Yeah. Is there a possibility that you don't get the track you would like to do?
I don't think so. No. I mean, we don't have limited spaces. So if you want to really like a track and you are eligible, I mean, for this master program, you can take the track you want.
Okay. And do you know the main difference between BME and the medical design track from industrial design?
Yeah, I think that is really oriented to the design part. So they really do only the design part, not any mathematics too much here, not neuro part, nor many. So mostly on some medical devices, they really design certain things, but not really very deep research like we do it in this master program. No. So it's quite a big difference. No.
Okay. And do you have partner universities abroad where you also could courses?
Partners, yeah, there are also this Ideal League, a lot of partners abroad, but also we have our personal contacts from different universities around in Europe, but also outside of Europe, definitely, yeah, even in Africa or in other countries. So, but we don't really have preferences. It depends. It depends on the project, yeah. Okay. But we have, yeah. Here, I mean, for instance, one of for a long time partner was ETH or also Cambridge University as well, Oxford, but also in France as well. We have quite a lot of partners.
Okay. Is there a lot of programming involved in neuromusculoskeletal biomechanics track?
Programming, yeah, it is quite many aspects. So yeah, there is we have some new I would say staff member in our department, which probably I'm not entirely because they're quite new and they really do a lot of programming here. So not per se totally, but they are quite.
Okay, wait a minute. Yeah, what's the application deadline for the master that starts in February?
February will not be any longer. So if they want to do anyone to start in February, it's still possible, but we don't really encourage too much because you will delay a little bit your program, you'll be a little bit, but the official starting date is September. If someone wants to start in February, they should send me an email and let me know. Usually it should not be later than, of course, the 1st of February, somewhere here. It is not an official time to start. This program, like many others in QDELP, especially in the CME, they start in September.
Okay. Is it easy to get accepted for the master? Or yeah.
Again, I'm asking who from where. If you are a Dutch student, of course, yeah, as long that you have an eligible bachelor for this master program, you'll be accepted. But if it's an international student, okay, the same thing. They have to really provide. There is a procedure for international students here, and they have to follow that procedure. And then, yeah, they will be screened by a committee, and they will get accepted. So it's difficult to say how easy. But
who is likely to get accepted for skills or experience or education?
No, it's mostly for yeah, it's based on the education, so the background what we have here. So actually for Dutch students, if you are eligible, you will get it. But for international students, definitely it's a little bit more. They have to. We need to judge their diploma, their grades, also other experience they have here. So are more criteria. I think these are well explained on the web page of TU Delft for international students. So we take those criteria which are developed by TU Delft. So we take those into account. So motivation letter, diploma, their grades, so many more aspects.
Okay. Someone likes to continue with a master in medicine after the BME master. What BME track would you suggest? And are there possibilities combining both field and future career?
Yeah, that's it's a little bit of personal things we don't really have, but I think, yeah, if you really want, if you are a medical, and probably track number 2 offers you quite a lot of opportunities in different directions, but I can't exclude, I've seen it also, students with a medical background, they also went to medical physics and even to track number 1, to neuromusculoskeletal and biomechanics. So probably it's just, yeah, suggestion for track number 2, but any other tracks would be possible.
Okay.
So this will, you will find out along the way. So probably not exactly in the first day, but after some discussion, introduction week with the people involved or other, yeah, and then we'll find it out. But
someone missed it maybe, but can you explain again the difference between BME and BMD?
So the difference between BMD and BME, the BMD is really mechanical engineering. You can develop specific or work for specific devices, but you are getting inspired from the nature and can design those devices for any, I would say, engineering field. But in the case of biomedical engineering, you design and you will be working in companies and I would say hospitals, but a biomechanical design will not end up in a hospital, for instance, working in a hospital or working for, or maybe in a medical company. Maybe they will be in an engineering company and they will design, for instance, an instrument which can be used also, a steerable instrument which can be also used for, yeah, for, I would say, medical application, but not per se.
Yeah.
So they will have definitely mechanical engineering background, mostly mechanical, but not too much, I would say, or maybe at all, knowledge about medicine or maybe about biology or human biology, anatomy. So those knowledge they will not have biomechanical design students.
Okay. Another question, is designing a prosthetic also something you are able to learn in this master?
Yeah, yeah, definitely, that's possible. Also, both in track 1 and track 2. Yeah.
Okay. Is it possible to do a double degree? What is the procedure?
Yeah, that's possible, but we need to, it's not possible, any combination. So yeah, we need to discuss about that, but it's possible to have double degree in this master. I mean, combine biomedical engineering with another one, for instance, from electrical engineering or from applied physics, but we need to see. Yeah. And also within mechanical engineering, for instance, it's not possible to do double degree between technical medicine and biomedical engineering, and also between biomechanical design and biomedical engineering. It's not possible.
Okay, thank you. This was it, I think.
Yeah. Okay.
Yeah.
Looks good.